Welcome to Teja Statistics. In this class, we are going to discuss about the range chart. By the definition of range, we have expected value of Ri, that is equals to d2 into sigma. So standard deviation of this Ri is equals to uh, d into sigma. So where d2 and capital D are constants, the control limits are given by UCL, that is expected value of Ri plus 3 into standard deviation of Ri. So what is expected value of Ri here? That is d2 into sigma. And what is standard deviation of Ri? That is uh, d into sigma. So if you common the sigma, then d2 plus 3 into d we got. So here it is denoted by capital D2, where d2 plus 3 into d is equals to capital D2. Similarly, LCL. What is an LCL? So expected value of Ri minus 3 into standard deviation of Ri. So d2 into sigma minus 3d into sigma. So if you common that sigma in both, then we will get d2 minus 3d, that is d1 into sigma. It is a symbolical representation, and also we are going to have the formulas for that also, and table values too. Okay, CL is equals to d2 into sigma. The above control limits are consisting of one parameter, that is sigma. Case 1, if sigma is known, then it is replaced by sigma equals to sigma dash. So UCL will become d2 into sigma dash, LCL will become d1 into sigma dash, and CL is equals to d2 into sigma dash. Case 2, if sigma is not given, that is unknown value, consider expected value of R bar, that is expected value of 1 by k into summation of Ri, 1 divided by k summation expected value of Ri. So the k gets cancelled, and this expected value of Ri d2 into sigma. So from that we need just a sigma value, so that is R bar divided by d2 is an unbiased estimator to the sigma. The control limits are given by, so UCL is equals to d2 into sigma. In place of sigma, what you have to substitute? Capital R divided by d2. So this will become d2, capital D2 divided by small d2, that is equals to d4, capital D4 they are writing, R bar. Next, since this is a value, since value. Next, LCL, layer control limit. So d1 divided by d2, it is denoted by capital D3 into R bar. Okay, from the above control limits, construct a range chart by taking sample numbers on x-axis and quality on y-axis. If all the sample points are lies between these two, LCL, CL and LCL, then we can say that the process is under control, otherwise it is out of control. Next, standard deviation chart, very important chart for the examination also. Okay, by the sampling distribution, we have expected value of SI is equals to C2 into sigma. Expected value of SI square is equals to n minus 1 divided by n into sigma square, where this expected values, after applying that, what is n here? That is sample size. What is C2 here? It is in a constant. Next, the control limits for standard deviation chart are given by UCL is equals to expected value of SI plus 3 into standard deviation of SI. So what is expected value of SI from the above? Expected value of SI observation is C2 into sigma. Substitute that value, and 3 into variance of SI is nothing but n minus 1 divided by n into sigma square under root value. So if you do the way if you use the variance of SI formula in expectations, expected value of SI square minus expected value of SI whole square. So substitute that value and you will get n minus 1 sigma square minus C2 into sigma square. So variance of SI is equals to n minus 1 divided by n minus C2 square of sigma square. So here we are going to use under root value also. We are just substituting the variance of SI value. So what is that? Completely we can change that into UCL as the beta 2 into B2 into sigma. So LCL will able to say that is B1 into sigma. What is CL is nothing but C2 into sigma. So case 1, if sigma is known, then that is replaced by LCL is equals to B2 into sigma dash, LCL is equals to B1 into sigma dash, and CL is equals to C2 into sigma dash. If sigma is unknown, then expected value of SI is equals to C2 into sigma. So here SI by C2 is an unbiased estimator to sigma. So here if you apply that one, so in the UCL formula, that is B2 into SI divided by C2. In place of sigma we are substituting SI divided by C2. So this will brings you the B4 into SI. What is B4 here? SI okay, so B2 into SI value. Similarly LCL is B3 into SI and CL is SI only. Okay, so the standard deviation from sampling distributions we have. From the above control limits, construct the standard deviation by taking sample numbers on x-axis and quality on y-axis. So sample numbers on x-axis and quality on y-axis. If all the sample points lies between UCL and LCL, then the production process is said to be under control, otherwise it is said to be out of control. Okay, up to this we completed our control charts for variables. Next now we have to see the control charts for attributes. What are these control charts for attributes? Okay, let's see what are these control charts for attributes. So first of all we had to look at the P chart. What is P chart? An error in a place of a product is known as that is defect. It indicates lack of quality of the product. An item consisting of at least one defect is known as defective item. Okay, so let us consider a population of manufacturing a product in which the quality of the product is measurable by introducing an attribute that is called defective. Here we may have the two chances. Every product have two chances, either defective or non-defective. Select a sample of size small n from the population in which x are number of defective products. By the definition of binomial distribution, let x have the binomial of n comma p. So here the expected value of xi will consider n into p. So variance of xi is equals to npq. Variance of xi is equals to npq. Now just to see the proportionality or the fraction defective, the number of defective products by total sample size. So p is equals to x divided by n. Expected value of p is equals to expected value of x divided by n. So expected value of x is equals to n into p. So n gets cancelled, we will get the capital P. Variance of p is equals to x divided by n. 1 divided by n square into variance of x. What is variance of x? np q, which is our binomial distribution value. Okay, so variance of P is equals to P into Q divided by N. So standard deviation of that value is PQ divided by N. Now construct a 3 sigma control limits for this. UCL is equals to expected value of small p plus 3 into standard deviation of small p. What we got here? The capital P plus 3 into under root of PQ divided by N. Now see, the 3 divided by root n will be gives you the constant value as a, which is our table value. So p plus a into under root of pq. LCL p minus a into under root of pq. What is CL here? That is p. From the above control limits, construct p chart by taking the sample numbers on x-axis and quality on y-axis. Okay, if all the sample points lies between UCL and LCL, then the production process is said to be under control, otherwise it is said to be out of control. Similarly, we can have NP chart or D chart. Okay, similarly we have NP chart or D chart. The number of fraction defectives per chart. An error in a place of the product is known as defective. It indicates a lack of quality of the product. An item consisting at least one defect, then it is known as defective product. Let us consider a population of manufacturing products in which the quality of the product is measurable by introducing the attribute defective. Every product we have two chances, either defective or non-defective. Select a sample of size small n products from the population in which D are number of defective products. By the definition of binomial distribution, we have NP. D follows NP. Variance of D follows NPQ. Therefore, the 3 sigma control limits for the D charts are given by UCL is equals to expected value of D plus 3 into standard deviation of D. So N into capital P plus 3 into under root of NPQ. Okay, LCL. So that is NP minus 3 under root of NPQ. Okay, CL equals to N into P. Case 1, if P is known, then it is denoted by P dash. Okay, you can see UCL, LCL and CL in place. Case 2, if P is unknown, then it is replaced by its unbiased estimator. Okay, for this consider the total population is divided into K groups with equal sizes D1, D2, D3 and so on. Dk are the number of defectives. What is D bar? 1 divided by K summation I runs from 1 to K of Di. Now consider D bar is equals to expected value of D bar is equals to 1 divided by K summation expected value of Di, that will gives you expected value of Di will gives you NP value. Okay, so that is what you are going to get, and this n gets cancelled and n will be there. Okay, so from that expected value of D bar divided by n is equals to P. So D bar divided by n is an unbiased estimator to P, an unbiased estimator to P. So from that we can say the UCL values. What are the UCL values? N gets cancelled. D bar plus 3 into under root of D bar of 1 minus D bar. Okay. Similarly, you may have the capital A values also. Okay, 3 divided by root n. Okay, LCL values also D bar minus A into under root of D bar of n minus D bar. What is CL? That is D bar. From the above control limits, construct an NP chart, or we can say that it is a D chart by taking the sample numbers on x-axis and quality on y-axis. If all the sample points are lies between UCL and LCL, then the production process is said to be under control. Otherwise, it is said to be out of control. Last but not least, this is C chart. Okay, this C chart and one more chart is there, that is U chart. We have in our syllabus, and we can discuss them in the next session. Thank you.